Good morning everyone. I'm Dr. S. Manasa, Assistant Professor from Aeronautical Engineering College, Dundigal, Hyderabad. Today I'm going to talk about the topic smart materials and their engineering applications. So coming to the topics in this smart materials, so we will have to talk about the smart materials and their engineering application, and there are some other alloys called shape memory materials and a polylactic acid. So coming to the smart materials, what are smart materials? Smart materials have the properties that react to the change in the environment. Their properties can be changed by external conditions such as temperature, light, pressure, electricity, voltage, pH, chemical compounds. So the smart materials are nothing but the materials that can react to the environment, means the external conditions such as temperature, light, pressure, electricity, voltage, pH are the chemical compounds. So then they can change their properties when they react to the such conditions. So these changes, why they are called smart materials is because the changes, whatever happens due to the external stimuli, can be reversible. They can be changed and can be repeated many times. So this is the most advantage of the smart materials, which cannot be carried out. Means the changes cannot be reversible with other materials. Hence, they are called as the smart materials. So these materials play a crucial role in various engineering applications and the other fields. So here, if you can see the different kinds of smart materials, like some photochromic spectacles and foldable photo frames, spectacle photo frames, and piezoelectric bodies, and quantum tunneling composites. And these are thermochromic that you have in X-ray, and this is micro encapsulation. That means you will encapsulate the material that can be formed as a capsule and release some amount of the particle which are you are loading inside them whenever they are needed. So this can be used mainly for drug deliveries. And polymorphism. Polymorphism means the material can be in the one or more shapes or the states. So it can be solid, liquid, powder. Only one material can be of different state, and it can be changeable, as I told just now. It is a reversible change that will happen. Hence, they are known as smart materials. The smart materials are also called intelligent or responsive materials. Are the designed materials that have one or more properties that can be changed, significantly changed in a controlled fashion by external stimuli such as stress, moisture, temperature, light. So these can be tuned in a significant change in a controlled fashion, like one after the other, or based on the requirement, which kind of the requirement you want. So based on that, one or the other properties can be adapted into the one material, or can have the different ways of tuning the material so as to get the your requirement. So hence they are known as intelligent or responsive materials. So let us see what are the classification of the smart materials. So there are different types of the materials that are known as the smart materials, which are taking highly the industry, high importance in the industry, so that which can be replaced by the regular used the metals or alloys or the plastics or different types of the metals which are absolutely can be replaced by these materials, and they can be very much widely used. So one of the different types of the smart materials is piezoelectric materials, shape memory alloys, and which are known as SMA. Next one is magnetostrictive materials, and then there are another is electrorheological and magnetorheological fluids, and smart polymers, thermochromic and photochromic materials, and hydrogels. So these are seven types of classification of the materials. So based on their properties, these are classified. So coming to the first type, that is nothing but the piezoelectric material. Piezo, the word piezo is nothing but that will produce electricity. So piezoelectrics are nothing but the materials that can produce electrical energy upon application of mechanical stress. So they commonly known as piezoelectric material is quartz. So you all of you know the quartz very well, but it is a piezoelectric material. And the mechanism how this materials act is it involves the development of electrical charge due to a movement of the electron upon application of the stress. So piezoelectricity was discovered in 1880s by Curie brothers in quartz crystals. So here you can see upon application of the stress, so the stress is applied here in order to push. So it is stress is released. So when the stress is applied, there is a electrical energy is produced here. Okay, this one is mechanical stress. And this is here you have another film picture. So the force is applied in this. So in order to the give the stress on the metal substrate, metallic plate. This is a piezoelectric material which is producing electricity here. And so this is the piezoelectric material. So piezoelectric material is nothing but the material that produce electrical energy upon application of the mechanical stress. So do you know what is a real, generally used example of the piezoelectric material? Let us see what is that. So this is the piezoelectric material. So this is the piezoelectric material. So when you apply stress here, what is happening? The piezoelectric element is attached here. It is a regularly used lighter. It has a piezoelectric element in this, and it will you apply a stress over this, then the electricity is generated because of the movement of the electrons from here to here, and the heat is generated here. You have the gas which is supplied from the another tube. So this is the very very good example of the piezoelectric material that we quietly see in our daily life. So the mechanical shock is converted to the electricity. So what is happening when you press? Mechanical stress is applied, then it will be taken by the piezoelectric material, and then this electricity electrons are passed, and the gas is supplied over this, and the heat is generated. So what are the engineering applications of these piezoelectric materials? So where they are used, so they can be used in sensors, actuators. So they are used in sensors for pressure, acceleration, and force force measurements as well as in actuators for precise movements in devices such as inkjet printers. So they are mainly used in inkjet printers and sensors. So, and one is energy harvesting. So where in energy harvesting is to convert the mechanical vibrations into electric energy and powering small electronic devices. So the best example is the smart watches that we use is a piezoelectric material. So in the smart watches, what we have, the wrist strap has the piezoelectric element in this. So when the you have what are all have the features that you have, you can get the blood pressure and heartbeat and count, walk count. So these are all obtained, means so many can be obtained. So the piezoelectric material that is present in this sensor, and it is directly the in contact with the radial artery. So based on that, your heartbeat is generated. That can be known from the your smartwatch that you have on your hand. So the energy harvesting things here you can see the car which is going, and it has the power generator. So because of the piezoelectric the track it has, so it can regenerate or the recharge the vehicle. And one more is the gym that you do, or the like based on your walking steps. So the energy is generated and that is supplied to the fuel for your vehicle. And this is a piezoelectric sidewalk. So if you walk here, the energy is based on your walking. The energy is created and it can be supplied to the some other like automobiles or the cars or vehicles. And this is solar aircraft. Solar aircraft you can see here. It all has this solar panel over which this produce electricity that can be used for the internal use of the aircraft. So this is one nothing but the thermoelectrical seat. So when you sit on that, based on your movements or the vibrations that are generated on the seat, that produce the electricity and it gets recharged. And these are some natural piezoelectric materials that are present in the nature itself. The one of the main natural piezoelectric material is the bone and tourmaline. This is Rochelle star salt and tendons and the sugar cane. DNA topaz is one of the piezoelectric material, and the dentine enamel quartz crystal. That is, these are all obtained from the nature and they have the piezoelectrical behavior. Coming to the next type of the smart materials, nothing but a sharp shape memory alloys or SMA. Shape memory alloy or the SMA is an alloy that can be deformed when cold but returns to its pre-deformed condition and remembered condition when it is heated. So here is nothing but from original shape to it can be deformed when you apply a force, and then if you heat it again, original shape will come. So let us have two example. If I take some plastic pipe, so it is applied and when it is applied force, when then it can be deformed. But if you heat, what will happen? It will melt. But there is no reformation. Whereas the SMA alloys, when you apply some force, they will get deformed. But on application of the heat, they can be reformed. The original shape is obtained. So this is the difference between the normal, the material what we have, and the shape memory alloys. So what are the applications of these shape memory alloys? So they can be used in aerospace industries. They are used in the deployed structures and adaptive wing components in aircraft applications, where the opening close of the wind will have a opening close of the wings of the aircraft can be there because of the wind forces. So morphine device embedded within the wing. So because of that, it goes to the it's a deformed stage on application when there is a high pressure wind. So and it comes to the original shape. So based on the pressures, wind pressures, it will change to original to again the final stage, and final stage has come to the original stage. So morphine device stretch resulting in wing area increase, and it is a compression where the area is decreased. Coming to the next application of the shape realize it, they are used in biomedical devices. They are used in stunts that can be compressed while insertion, then can expand due to their shape memory, original shape within the body. So let us take one example. So let us take one stunt. This is one example I'm talking about. If you have some blockage over your heart block or something in your blood vessel, then you are putting some stunt. This is a stunt that you are keeping in order to open up the, because here your blood vessel is blocked, so this has to be open. So when you are inserting, it is small in size. When it is inserted, then it will increase its size. It will be deformed in order to increase the width. Then it will be in its position so that the blood is flowing into the blood vessels. So here these shape memory alloys can be used. So and in the dental applications where the dental clips are applied in order to drag the get the all teeth in a same series or the place, they can be dragged down. So here the shape memory alloys only are applied. So they are initially tightened in order to have the teeth to come to the its original position. And these are flexible. The spectacles that we see, these are already obtained in the market. So because of the shape memory alloys, though you bend also, it can be there for a time being, and later on they can be released, or it is coming to the original position. And then here you can see the bioelectronic sensor that you have cleaned there, and the autonomous active stents with the surface patterning. They can be used in the hard blocks and all. So these are different applications that are present for the SMA shape memory alloys. So they can be used in medicine, optometry, engines, aerospace, and in robotics, automotive, pipings, civil structures, water sprinklers, textiles. So here are a few examples. Medicine, it is like robotics. Robotics, when you have like something, it has older, then it will release. So it will come to its original place, deformed structure, original place. So here, and artificial hands kind of things. Here in aircraft application, and for the sutures, clips that they are applied. Applications of shape memory alloys, you can see aeronautics and complex and solid state actuators. And orthodontic actuators are there, is not older. And SMN bone staple. Here in robotic application, and as SMA damper also, high glass frames, and SMA thin films and MEMS, and SMA art applications. So these can be like when you once you press here, it is deformed, but again comes to the like deformed, then like it's like a spring nature. It will come to its original position. So the next type of the materials of smart materials are nothing but the magnetostrictive materials. So by name itself, it is saying that magnetostrictive. So materials that convert electromagnetic energy into mechanical energy and vice versa. So here you can see an application of the electromagnetic uh, materials are used to convert the electromagnetic energy into mechanical energy or vice versa. So these materials, when you apply a stress at one direction, all north phases are come one side, and when you apply a stress over the other direction, the all south phases are come. So these are magnetostrictive materials that are used to convert electromagnetic materials into the mechanical energy. This effect can be used to create the sensors that measure the magnetic field or detect the magnetic force. These materials change their shape in response to an applied magnetic field. So, what are the engineering applications of these magnetostrictive materials? They are utilized in sensors for measuring the magnetic fields and as actuators for precise control in robotics. So you can see here, then when load is applied, this is a rigid frame you have. When load is applied, the electrical energy is generated. When it is vibrating part, here is a mass that is applied and the electrical energy is generated. It is used in sensors for measuring the magnetic field and as actuators for the precise control in robotics. Coming to the next type, electro-rheological or magneto-rheological fluids. So these electro-rheological or the magneto-rheological fluids means these are the fluids whose viscosity can be changed in character or composition by application of electrical energy or magnetic field. So what are the applications of these electro-rheological or magneto-rheological fluids? They are dampers, shock absorbers. So they are mainly used in dampers and shock absorbers. So they are where they are present. They are present in the automotive and industrial application to address the suspension characteristic based on the changing conditions. So here you can see two diagrams with the positive and the negative electrodes are there, and the electro-rheological fluid is there. So it is before application of electric or magnetic field. So when you applied the electrical or magnetic field, electrical field, the electro-rheological fluid has formed as a oriented forms, or there is a direction. It is non-uniform. It is uniform lines of the my electro-rheological fluid has formed on application of the electricity. Coming to the next type, those are smart polymers. So what are these smart polymers? Smart polymers are nothing but polymers that undergo reversible changes in their properties in response to the external stimuli. So the smart polymers has a significant change in structure and properties and can be induced by very small stimulus that makes them unique and effective. So these polymers are different from the polymers that are available in the market because they have significant factor that can be tuned or changed by applying small stimulus, and the factors can be changed by the orientation of means they can be one by one can be changed and have the multiple properties in one polymer itself. So these application of these smart polymers are highly appreciable and they are widely used in different fields. So let us see what are the applications of these smart polymers. They are used for sensors, actuators, such as artificial muscles and production of hydrogels, biodegradable packaging, and they are also used in biomedical devices as a drug delivery systems and are responsive coatings for the medical implants, and they also have used as a textile for they are responsible fabrics for the textile industry, like they can detect the moisture management and the color changing textile can be there. So these are all different types of the applications that are you obtained by using the smart polymers. So let us see what these smart polymers, what are the applications. They can be used in artificial muscles and sensors and actuators, and the separation and purification methods, and shape changing fibers also we can use, and microfluid devices we can develop as viscosity modifiers we can use, and they can be used as a controlled release and as also self-healing materials. So let us come to the next topic, which are nothing but thermochromic or the photochromic material. So this is very interesting topic, nothing but the photochromic material. What is photochromic material? Photo means what? Light. Chromic means color. So photochromic materials are the materials which can change their color when irradiated with the visible or the UV light. So when light is radiated on the materials, that can change the color. So these are called photochromic material. So here you can see this is a very well example of photochromic material. This is what chameleon. So what happens? These are the nanoparticles that are present on the surface of the body of the surface of the chameleon part. So when the light is irradiated on the surface of the nanoparticles present on the chameleon, the particular wavelength of the light is reflected out, which is reason for the different colors that are present in the chameleon. There is a change in the color with respect to the light that is formed or the reflected out. So there is a change of the colors for the chameleon based on the environment. So next coming to the thermochromic material. What are thermochromic material? Thermo means heat. Chromic means again the same, color. So, what are thermochromic materials? Thermochromic materials are nothing but the materials that have a change in the color when they are heated above or below the threshold temperature. So, some material has a stable temperature, which is nothing but the threshold temperature. So, if it is heated above or below is the its threshold temperature, it gives the change in the color. So they are named as thermochromic materials. So what are the applications of these thermochromic or photochromic materials? These thermochromic materials are used in the these photochromic materials are used as the smart windows. Here you can see one example what is happening. There is a change, means on off system. Okay, so it is because of water based on the temperature. So this is a thermochromic or the window changing system that is already present in the foreign countries. They are using based on the heat or the light when it is fall on the glass substrate. There is a, like, it can be seen or not seen. These are smart windows. They adjust automatically and then tint based on the sunlight intensity. And these materials can be used in packaging also as indicators of the temperature. So these are one example. This is one example of the chocolate. You can see when it is warm the color of the chocolate is white, and when it is cold it is blue in color. So you can see by without opening it, you can observe whether it is cold or warm. So this is the one of the most important or emerging applications that can be used in every food packagings, even food. You can see, you can know by its color itself whether it is hot or cold or good or spoiled. That can be used as a sensor. These thermochromic materials are thermochromic materials are used as the sensors to identify the packaged food. This is one of the major emerging applications. Coming to the photochromic lenses, another applications of photochromic materials is you can see here when there is a cloud or there is less sunlight, it is the glass is transparent, and when there is a heat, the kind of shield or it is becoming dark in order to stop the direct sunlight to focus onto your eyes. So these are photochromic lens which are already are in use in the market. So these are photochromic lenses. Then coming to the hydrogels. What are hydrogels? So by name itself it is saying hydro means water. Water. Gel is nothing but three-dimensional surface of the structure cross-linked polymer network. So hydrogels are nothing but the cross-linked three-dimensional polymeric networks that have water in them. So when the cross-links of the gels are blocked, means are filled with the water, they are known as hydrogels. So they are also considered as the smart materials. Let us see how and why they are considered. So you can see here one example, the hydrogels. So instead of water, they have loaded some drugs here into the cross-linked spaces of the hydrogels. So when there is a change in the pH or variation in the pH at particular pH, the drug molecules are released out. And when there is a variation in the temperature, so they can be the pH dependent and temperature dependent. So these are, see here also the drug molecules are out. So where they are used, so this example itself is clearly saying this can be used in drug industry. Okay. So these are nothing but water absorbing polymers because they are hydrogens that can change their size and shape in response to the environmental conditions such as temperature, pH, etc. etc. So based on the factor, they can have the change in the structure or shape. So based on that, we can use in the different fields. So let us see what are the engineering applications that hydrogels can be used. So the most common example is the gels, the moisture creams or the gels that we use in summer. So you can see here they will protect your skin because of the, so here they are, the gels are loaded with the water and some the UV protecting particles which are loaded into the hydrogels, and they are applied on the skin. And the balls, water balls, you might have seen everywhere outside. So these balls have, when they absorb some water, when they are put in the water, they get enlarged and they give some, they put some colors to the balls and they will put in water. So what will happen? They will give some aesthetic appearance because of the color in them, and By absorbing water, they will form the enlarged balls, so they can be used in decoration purposes also. And the most common hydrogen that is used in is tissue paper that we use in our daily life. So the paper looks very soft because it has the hydrogel particles in that. So when the water is like when you is in contact with the tissue paper, it gets absorbed, means water gets absorbed, and the tissue paper gets wetted and it will be very soft. So this is the one of the daily use example of the hydrogels. These hydrogels can be used in making the lenses also, and these are the films, hydrogel films, which can be used, and can be used in moisturizers, creams, and for eye lenses, and also for the bone fluid. So in order to have the interaction, the bone interaction, to decrease that, nowadays they are using in this this fluid in fluid repair problems of knee joint pains also. So the engineering application of smart materials continue to expand as the researchers and engineering explores new ways to leverage their unique properties for innovative solutions across various industries. So coming to the next example of the smart meters is polylactic acid, which is shortly known as PLLA. So polylactic acid is chosen as a polymer with the shape memory alike properties. So the PLLA is because why it is chosen is because it's a nature of biodegradable and bioactive, which is a thermoplastic, which is made from the renewable sources such as starch and sugarcane. So let us see how it is prepared. So it is the source. So it is taken from corn. So corn starch is taken. This is a starch obtained from the corn, and it is treated with the lactic acid. So in order to produce the and polymerize it in order to produce the polylactic acid. So this is the structure of the polylactic acid. So if you want to prepare industrially, so lactic acid, cycle lactide monomer, it will polylactic acid will form as a lactide monomer, and then give the polymerization of the process will occur in order to give the polylactic acid. This is the polylactic acid. So what are the properties of this polylactic acid? Polylactic acid exhibits a wide range of properties that make the suitable for various applications such as because it is biodegradable. Why? Because it is obtained from the starch, corn starch, so it is biodegradable, making it environment friendly, and it is biocompatible too. It is safe for using in different industries like medicine and food contact application due to its biocompatible nature. And next one is its transparency. It is very transparent in nature and can be made into clear and glossy products. The next one is it can be it is a renewable source of. So PLLA is there from water. It is a renewable source, nothing but the corn. So starch and sugarcane. So hence it is a renewable source of energy. And it has a rigid, it is very rigid. So it has a rigidity property. It offers good rigidity and can be engineered in similar strength in conventional plastics. So it can be a replaceable to the conventional plastics, and it can be a transparent and very good material, and it is heat resistant too. It has another property which is heat resistance. So PLA has a moderate heat resistance but may be deform at relative low temperature, limiting its use at high. So it cannot be used for high temperatures, but moderately it is a very well smart material, and it has a brittleness also. So this PLA can be somewhat brittle, which can affect its use in application requirement, impact resistance. So in applications requiring impact resistance, and it also has the barrier properties. It has a reasonable barrier properties against the moisture and the gases. So it can be used in as a barrier material, as it has barrier properties against moisture and the gases. So these are applications of polylactic acid. So in textile industry, in making threads, and in this what we say is transparent spoons that are obtained, means that we use in the food, so that can be used, and this in packages, and also in textiles, and in this is construction, and in medical purpose we can use, and in agricultural purpose, everywhere in printing and all we can use this one material, and in here also we can use different applications are there. So what are uses of polylactic acid? These are nothing but applications. What are the applications of okay, till now we have studied what are the characteristics it has, but now what are the applications where they can be used? One is in packaging, for producing the biodegradable and compostable packaging materials such as disposable cups, food containers, and films. In food industry we can use this PLA, and in textile industry this PLA fiber, means when it is made as a fiber in textile industry, they can be used to produce the biodegradable and sustainable fabrics, because the other fabrics which are used may not be degradable. So if you use for the very long time, it is very like its degradation will be a difficult factor. So PLLA can be a good replacement in fabric or the textile industry, as it is biodegradable. And also where PLLA can be used is medical and healthcare. So it is used in medical devices such as sutures, tissue engineering, scaffolds, and drug delivery system due to its biocompatibility. So this is accepted by the human body, and there is no toxic or the adverse effect of the PLA if it is sent inside the body or consumed by the human being. So hence it can be explored in the medical and healthcare applications also. The next one is 3D printing. Here you can see this is 3D printing. It's a popular material for 3D printing due to its ease of use, biodegradability, and availability in various colors also. So because of which it can be used in 3D printing also. It can also be used in filaments. It is used in the manufacture of filaments for fuse to deposition model FDM in 3D printers. So in 3D printers also it can be used as a filament. So okay, and as a biodegradable films also. PLA films are used for agricultural applications such as mulch films, and they can be plowed into the soil after use, so they can get degraded after their usage. They can be used as a disposable tableware also. So PLA produces disposable plates, bowls, and utensils for single use. So once if you use and then can throw, it is not biodegradable. It is degradable, so they can be used as a use and throw plates, bowls, etc., etc., as a disposable materials. And where they can be used, as a consumer goods also it can be used. It is found in consumer goods like toys, cutlery, and cosmetic packaging also. So this can be one of the applications as a consumer goods as packaging and in making toys also in packaging the cosmetic materials. So this is the preparation. This is a synthesis, how it is prepared from the corn starch polymerization. Then you will produce the polylacticals. So where and all it is used in tissue engineering, in drug delivery, in agriculture, automotive, packaging. So these are all different applications of polylactic acid. You can see what are the parts, the materials that has. So it majorly has the starch blends. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.